In this video, we're going to look at various graphs of functions and we're going to find the equation of those functions. So I'm going to start with the parabola, square root, and rational function because the steps for these ones are very similar to grade 10. Now, we know that we have 4 different types of transformations for your A, K, D, and C value, but we really don't care about the K value, which would be your horizontal stretch, compression, reflection for these ones. And the reason is because you can actually combine your A and K value by simplifying your function and minimizing the transformations. So let me just show you an example with a parabola. So if you have a parabola like this, you might say that compared to the parent parabola, let's say it looks like this, that this parabola has been horizontally stretched by a factor of 2, let's say. But you can also look at it as saying that your parabola has been vertically compressed by a factor of 2. So you can actually state the same transformation in 2 different ways. So as a result, we don't really care about the K value for these specific ones. Now, with a parabola, when you have reflections over the y-axis, the parabola will look the same. Even with a rational function, a reflection over the y-axis can be the same thing as a reflection over the x-axis. So again, we don't care about the K value. But for a square root, you do have to pay attention to see if your K value should be negative. You don't have to worry about stretches, compressions, but you will have to look for a little reflection there. So for these functions, we want a f at x minus d plus c. The letters don't matter, but pretty much the first thing you want to start with is finding your key point that moves because of a shift. So for a parabola, that would be the vertex. For your square root, you're looking for the tip of the square root. For the rational, you're looking for the asymptotes. The asymptotes will tell you what that shifting is. So step 1 is your shifts. Step 2 is find another point and plug it in for x and y to solve for a. And that is exactly what you did in grade 10. So sub in point and isolate a. So let's try it out with this parabola. So my parabola vertex is right here. The vertex used to be at the origin. So my parabola must have shifted to the left 5 and then up 7. So the way I would write that is y equals a x plus 5 to show that I'm going to the left 5 and then squared and plus 7. So the only information we need now is a. And again, I don't care about k because k can become a. Now, let me find a nice clean point that I can read off. So I want a pretty point, and by that I mean the x and y values are integer values. So let's say this point right here. It is -4, 5. So for y, I'm going to put 5, and for x, I'm going to put -4. And just like in grade 10, I'm going to isolate for a. Now, what I want you to do, bring that 7 over so you don't accidentally collect it with a, even though they're not like terms. So I have 5 minus 7 is -2. And then -4 plus 5 is 1, and 1 squared is still 1. So there's nothing for you to divide out. The a value is -2. So we can put this all together, and I am going to bring back my function notation and write f at x equals -2. X plus 5 squared plus 7. And there's your parabola. Let's try the square root. So my key point is right over here. It used to be at the origin, so we've gone to the left 4, up 3. Make sure you're careful and you look at your scale. So then I have y equals a, and then under the square root, I'm going to write x plus 4 to show the shift left, and then plus 3 outside the bracket. Now, if I look at my square root, it is going towards the right, which means it has not been reflected over the y-axis. If it had been reflected over the x-axis, that's not a big deal. That would come out when I solve for a, just like with the previous parabola. It was reflected, but when I solved for a, I found that negative value. So here, K is still positive because there was no reflection over Y. So let's find a nice clean point that we can sub in. Now looking at this, I don't see any points that have a nice whole number, but this is still a decent point, 0, 3.5, because I can clearly read it off. So I'm going to put 3.5 for Y, 0 for X, and just like before, I'm always going to move that up-down number to the left. So 3.5 minus 3 is 0.5, and then 0 plus 4 is 4, and the square root of 4 is 2. And I don't want to write a times 2. I'm just going to write 2a because that looks a little nicer. And if I want my a value to be a nice fraction, I'm also going to rewrite that 0.5 as a half. And now I'm going to divide both sides by 2, or instead of dividing by 2, I can multiply both sides by a half. So now I can clearly see that my a value is 1/4, and then I can put it all together. F at x equals 1/4 square root of x plus 4 plus 3. And there it is. Now, let's do this rational example on the bottom right, and then we'll look at some other functions, and we'll go back up to the tips and tricks. So for this rational function, I first want to highlight where my asymptotes are. So I have one at -3 and -6, which means my rational function must have shifted to the left 3 and down 6. So that's the first thing I'm going to do. Y equals a, and then x, I'm going to the left 3, so I should write x plus 3 in the denominator, and then -6 outside the bracket. And there we are. And again, I don't care about the k value because I can combine it with the a. I don't even care about reflections in this case. But here I can see that there was no reflection because the curves are in the top right and bottom left corner, just like the base function. Now, let's pick a nice clean point that we can read off. And I'm going to pick this point here, which is -2. And that point is halfway between -5 and -6, so -5.5. So -5.5 for y, -2 for x. I'm going to bring that -6 over, so -5.5 plus 6 is going to be 0.5, which I'm just going to write as a half. And then -2 plus 3 is 1. And 1 over 1 is still 1, so we have our a value right away. There's nothing we have to divide out. So let's put it all together. 1/2 for a, 1 over x plus 3, -6. And that could be your final answer. Now, let's try something else. So let's look at the sinusoidal because there's one on the left. So for this one, you really just want to look for your properties. And for sinusoidal, we do care about the k value. So I'm just going to write this in terms of sine, but of course it could be cos. So A would be your amplitude. Look for that. C is your midline. K, you can figure it out if you identify the period. We know that usually the k value gives us the period. So the period is 360 divided by k. But we can also do it backwards and say that the k value is 360 divided by the period. And then D is your phase shift, and that really depends on what you choose to be the starting point. Okay, so there's actually an infinite number of possible sinusoidal functions for any given graph. Okay, and then for the a value, make sure you also look for reflections, and that really depends on your starting point as well. So let's go down to this sinusoidal function. I like to highlight my maximum and my minimum, and then if I see that they're at 1 and 5, halfway of that would be 3. So now I can clearly see that my amplitude is 2 units and my midline is 3. So I'm just going to start filling in the blanks a little bit. So the amplitude is 2, but I'm leaving space in case I want to put a reflection. I haven't even chosen if I'm going to put sine or cos. I know I'm going to have a k value and a potential phase shift in there. And then I'll put the +3 at the end. Now, let's try to figure out our period. Now, looking at this, I actually can't find a full cycle. I can't see it. But I do see that I'm going from a minimum at -240 to a maximum at 300. So this would be half a period. So from 300 to 240, that's 540 degrees for half the period. So if we double that, our actual period is going to be 1080. So then I can find my k value by doing 360 divided by 1080, and you get 1/3 for your k value, which makes sense because a k value of 1/3 means that you have horizontally stretched your sinusoidal function by 3. So if I take 360 and multiply it by 3, then I get that giant period that is presented in front of us. So the k value is 1/3. Now, I can actually write this function in different ways as sine or cos. The choice is really mine. Let's say I want to do sine. If I want to do sine, I know that sine starts on the midline. So I look at my midline and I see this is the only point on it, which means the sine function that used to be on the y-axis has moved to the right 30 degrees. So then I would have to show x minus 30 degrees to show that movement. And because from that midline point I'm going upwards towards the maximum, I don't have to worry about a reflection. So that's one possible equation for this function. But I can do another one. Let's say I really want to do a cos function. My amplitude is still 2. And let's say I choose this maximum value, which has moved to the right 300 degrees. My k value is still 1/3, but now I'm doing x minus 300 degrees, and the midline is still 3. And because I'm using the maximum value, I don't have to worry about a reflection. But I can do another equation if I want to, because I know that cos can also start at the minimum, which is right here, which means we're actually moving to the left 240 degrees. And if we're at a minimum, that means that our cos function would be reflected. So I'd make my a value -2. The k is still 1/3, and I'm going to the left 240, so plus 240 degrees, and then the +3 at the end. So I can write the same function in 3 different ways in this scenario. You really only have to present one, but you have options. Now, let's look at exponential, and then we'll finish the rest of them off. So with exponential, I actually don't care about a right-left movement. I don't care about a k value. All I care about is finding the vertical stretch, compression, or reflection, finding the up-down movement, and I need to figure out what my base is, because I know with exponential, it doesn't have to be 2 to the power of x. So our equation is going to be a, the base to the power of x, and then plus c. C is your asymptote. You can get that right away. With exponential, you're going to have to plug in 2 points. The first point you're going to plug in is the y-intercept. Sub in y-intercept. And when you do that, you know the y-intercept always has an x-coordinate of 0. So when I do b to the power of 0 here, anything to the power of 0 is 1. So that variable disappears, and then I can actually solve for a. So sub in y-intercept to solve for a. Then your next step is sub in another point to find your base. So let's try that out. Let's find an exponential, and here it is, this one on the top left. Now, first thing I want to do is highlight my asymptote, and I see that my asymptote is at 4. So I know that I have y equals, I don't know a, I don't know my base, but I do know my asymptote has moved up 4. Now, yes, you might look at this and say, oh, there's a reflection. I don't care. It will come up when I solve for a. Okay, let's identify our y-intercept. And you always have to start with the y-intercept because that will make a variable disappear. So my y-intercept is 0, 1. So I'm going to put 1 in for y, 0 in for x. And if you look at that, b to the power of 0 is 1. So you're really just left with a plus 4. Bring that 4 over, and 1 minus 4 is negative 3. So now I have my a value. So I'm going to replace a with negative 3. And now the only thing I'm left with is I need to find my base. So pick another point that you can clearly read off. And I like this point here, 1, negative 2. So I'm going to put negative 2 in for y, 1 in for x, and then the plus 4. So I'll bring the plus 4 over. Negative 2 minus 4 is negative 6. B to the power of 1 is just b. So now I can just divide both sides by negative 3, and I get 2 for my base, which means f at x equals negative 3, 2 to the power of x, plus 4. And do a logic check. Like, does it make sense that this has been reflected over the x-axis? Definitely. Does it make sense that the asymptote's at 4 and it's been shifted up 4? Yes. Okay. Let's go to our next one, which is a square root function. Now, notice here that the square root has been reflected over the y-axis. This you cannot find in your a value. So here, k has to be negative 1. There's no other way to get the square root to go towards the left. So my key point is 3, 1. I don't know a. Now when I put my square root, k has to be negative. You can write negative 1 if you want to. Open up a bracket, and I'm going to the right 3, which means x minus 3. And it's super important that the k is factored out or else your phase shift is wrong. And then plus 1 for the up 1 movement. Now, everything's the same as before. I want you to pick a point that you can clearly read off. So I'm just going to say 2, 3. And I want you to pause the video, plug this point in, and finish this question off. Solve for a and put it all together. All right, so you put 3 in for y, 2 in for x, bring the 1 over, 3 minus 1 is 2. And then here, think of BEDMAS. 2 minus 3 is negative 1, but that's not a problem because negative 1 times the negative is positive 1. And then the square root of 1 is 1, so you have found a right away. Let's move on. Here we have another sinusoidal function. So I want you to first highlight your key points. I see where my midline is, I see where my maximum is, and I see where my midline is. Using this information, I want you to pause the video, state your amplitude, state your midline, state your period so that you can find k. Try to do all of that and try to come up with an equation, and you can choose if it's sine or cos. And then come back to the video to see where you went right or wrong. So do your best and pause the video. Okay, so I know my midline is at negative 5, and my max and mins are half above and below that, so my amplitude must be 0.5. For my period, I'm just going to look at from here to here for a full cycle, so from midline to midline, and that's 180 degrees. So that your k value, if you do 360 divided by 180, is 2. Now you have flexibility of what you choose as your key point. So if I choose this as my key point, it is a sine function because it's starting at the midline, but it's going down, which means I have a negative sine function because it must have been reflected. So I'm going to put negative 0.5 sine. Then my k value is 2. But because my key point that I chose is right on the y-axis, I don't have a right-left movement. So that's great for me because I'm a little lazy. And now my midline is -5, so I can subtract 5 from that. And this is one option, and this is the simplest option because you don't have to worry about the right-left movement. But of course, you can try something else. Maybe you wanted a positive sign. So maybe you chose this point here, which is 90 degrees to the right. Or maybe you chose the one that was 90 degrees to the left. So you could have also had f at x equals positive 0.5 sine 2 x minus 90 or x plus 90, depending on what you chose as your key point. So that would have been perfectly fine. Or maybe you wanted a cos one, although for me, I wouldn't want the cos because I don't really feel like estimating where this point is. But you could have chosen that as a key point for a maximum cos and said f at x equals positive 0.5 because it's at a maximum. And we're going to the left 45 degrees. There you go. Or maybe you wanted a minimum start. If you start at a minimum, your amplitude would be negative, or the a value, sorry, would be negative. And then you're going to the right 45. So there's lots of options, and I haven't even written all of them, but you can write the same thing in different ways and they would all be correct. Now, let's try our last one. It's an exponential function. So I want you to pause the video and then identify your asymptote and set up that original equation. Then come back to check your work. So your asymptote is at -5. So hopefully you wrote y equals a b to the x minus 5. Now, identify your y-intercept. Pause the video, sub it in, and solve for your a value, then come back to check your work. Your y-intercept is 0, -3. So here we are. I'm going to bring the -5 over. -3 plus 5 is 2, and b to the 0 is 1, so a equals 2, which means I have 2 b to the x minus 5. And now, again, pause the video, pick another clean point that you can see and read off nicely, sub it in for x and y to solve for your base, put it all together, then come back to check your work. Okay, so the only clear point that I can really see is -1, 1. So I'm going to plug in 1 for y, -1 for x. Now I'm going to bring that -5 over. And when I do that, I have 1 plus 5, which is 6. I have to divide out the 2 first. I can't deal with that -1 at the moment. And here's what I have. 3 equals b to the -1. I need to get rid of the -1. So what I'm going to do is raise both sides to the power of -1. And the reason is, if you think about your power to a power rule, -1 times -1 is +1. So then I've eliminated that exponent above b and just made it +1. Then 3 to the power of -1, if you think about your knowledge of negative exponents, I need to take the reciprocal of 3. So I have a third as my base. And now I can put it all together. So 2 times 1 over 3 to the x minus 5. And make sure the 1 over 3 is in brackets and the x is on the outside, or else it would look like the x is only applied to the 1, but it has to be the whole fraction. Now, just one more little note here. Whenever you're solving this, if you have a value for your exponent other than 1, then you're always just going to raise both sides to the power of the reciprocal. So let me just do a little side note here. Let's say you ended up with 4 equals b to the power of 2. So here I know you can square root both sides, but you can also just raise both sides to the power of 1/2. And then you can plug that into your calculator. Or if you had, let's say, 2 equals b to the power of 1/2 for some reason, then you can raise both sides to the power of 2, which is the reciprocal of a half. And 2 squared is 4, and then that would be your b value. So you can always get rid of that exponent by raising it to its reciprocal. And that's it for finding equations. So let me just do a quick little recap. So for parabolas, square roots, and rationals, pick that key point for your right, left, up, down movement, then sub a point in to solve for a. Just for the square root, remember to look out for the reflection over the y-axis. For your sinusoidal, identify your amplitude and your midline. Identify your period to get the k value. Then you have the freedom to pick your starting point, and that will decide if it's sine or cos, and if there's a reflection or not over the x-axis. And then finally, for your exponential, start with the asymptote to put it in for your up-down. Plug in your y-intercept first to solve for a, and then plug in another point to solve for your base.